This video is on the objective identify and understand the null and alternative hypotheses for an experiment with two population means. Okay, so now we're getting into doing hypothesis testing about two population means and comparing them. Are they equal? Are they not equal? Is one bigger than the other? That kind of stuff. The setup is still kind of the same. Right? When you go through the steps of a hypothesis test, right, some claim is made, and then based on that claim you form a null and alternative hypothesis. The null hypothesis will always involve equals in some way, and that will be assumed, and then you'll decide whether or not you want to reject that later. And the alternative hypothesis will not involve equals, right? And that alternative hypothesis also tells you what kind of a test you're doing, right? A one-tailed or two-tailed test, right-tailed, left-tailed, or two-tailed. All right. So here's this question. Now again, if you are unfamiliar with the topic, want to see more about it, what they're showing you, click on more instruction, look at their videos, their examples, their notes, and hopefully those help you. All right, so here the question is, identify the null and alternative hypotheses in the following scenario. All right, so to determine if computer 1 starts up faster than computer 2, the mean startup time of two competing computers is compared. The shorter the startup time, the faster the computer. 25 startup times are randomly sampled from each computer, right? So there are two samples, right? Two samples, 25 that are the same model as computer 1, another 25 that are the same model as computer 2. So these are really coming from two different populations, right? We're talking about testing two population means here. Both populations have normal distributions with known standard deviations. Again, we're not doing the whole test here. We're not completing the whole test. All we're asked to do is set up the hypotheses. All right. So I'll go to a piece of paper here, and let's say, again, we're dealing with two population means now. So let's say mu1, mu sub 1. Say this is the average startup time or the mean startup time of computer 1, models like computer 1. The mean startup time for, again, this is for the computer 1 model. And we have this second population, right? All the computers of model 2, computer 2, and what's the average startup time for all of those? Right? So a second mean, a second population mean, I'll call mu sub 2 or mu 2, not like the Pokemon. And this will be the mean startup time for computer 2. Alright, and then just like with any hypothesis testing, I've read through this, it says, they're trying to determine if computer 1 starts up faster than computer 2. So like the claim here would be that the startup time for computer 1 is less than for computer 2 on average, right? If it starts up faster, it has a smaller startup time, right? A lower startup time. So their claim is that, or what they're testing, what they're trying to determine is if the mean startup time for all computer 1s is less than the mean startup time for all computer 2s. And again, that would imply that computer 1 is faster than computer 2 on average. All right, then what's a claim? Something that is being determined or tested or believed. Once that's established, then you can establish your hypotheses. The null hypothesis, the alternative hypothesis. Okay. And just like before, this claim does not have equality involved. It's just less than. So that is going to be the represented by the alternative hypothesis. So mu1 is less than mu2. And then remember, the null hypothesis and alternative hypothesis should be opposing statements. So the opposite of is less than is greater than or equal to. So the null hypothesis is that the mean startup time of all the computer 1 models is greater than or equal to the mean startup time of all the computer 2 models. Now, again, perfectly valid null hypothesis. All right, we're actually going to see that showing up this time. But remember, most times though, we're going to use just what's being assumed. Right? Later, when we actually do more steps. For right now, this objective is only on this first step, setting up the hypotheses. But later on, when we perform more steps, we're going to be assuming the equality. We're going to assume that the two speeds are equal. Right? They're just as fast as each other. And also, later, when we perform more steps, this alternative hypothesis tells me what kind of a test we're running. Remember, you have a mu1 is if it's a is less than mu2 like this, or you could also write this way. It's an inequality. If you subtract mu2 here, you'd have mu1 minus mu2 is less than 0. So you have some parameters. Right, population means over here is less than some value. Well, when you had parameter less than a value, that was a left-tailed test. And if you recall, from earlier hypothesis testing, what kind of a test you have, a left-tailed test, a right-tailed test, or a two-tailed test, that determined how you would figure out the critical values, if there were one or two critical values, or if you were doing that p-value method, right? It would determine how you would calculate the p-value. And this is all. Right, this is all we're asked to do here, is set up these hypotheses. So null hypothesis, mu1 greater than or equal to mu2. Alternative hypothesis, mu1 less than mu2, and I've already selected that back here. Right. And then we'll submit. Again, please read your answer explanations. Right. So they do explain a little bit. And I believe that's all. Let's see if there's a second part to this question. And there is not. Okay, so hopefully watching me do that one helps you when you work on this kind of thing on your own. Thank you very much for watching.